Morning, everybody. It's um, Sunday, um, February 21st, right now. As I record this, this will be ready for Monday, week 8, starting February 22nd. Um, it, no one has asked for an extension because of the winter weather. But if you're having trouble, hopefully you will reach out to me. I'm sure you all got uh, messages from the university regarding these unprecedented winter storms. Anyway, today this is our last week devoted to data science. It goes into blockchain now, which disappoints me, but that's the way the university wanted to construct the course, so that's what we will do. So today the topic is data mining, kind of as it relates to what would be more traditional data analytics. Um, kind of like, and there is a difference. A lot of these, there's a lot of overlap. I mean, there's a lot of commonalities and whatnot, but there's a distinction. So this week, I have posted a very robust um, lecture. A colleague of mine at the University of Central Arkansas put on a data mining warehouse, data mining um, and machine learning workshop using the R programming language. And as you all saw, I posted an announcement with Dr. Worley's introduction to R. So you guys will have access to these two lectures. If you want to learn R between the two of these, they're pretty informative. Um, so yeah, this week, all you're doing is a discussion board. You know the difference between data mining and data analytics. I'll give you a few points here, but then I encourage you to watch that video. Hopefully you have found my YouTube channel. You can watch any of those videos, like when you're driving down the road or listen to them on your headphones or whatever. Um, Hopefully save some time. Anyway, data mining and analytics. Um, Come on now. There we go. So we'll do yeah, what is data mining, what is the analytics, and then your discussion question. Um, no, we're not doing dissertation foundations. Good grief. You guys would be really lucky if I ever get through a methodology without a cut and paste error. If I ever get through a lecture without a cut and paste error. All right. So data mining um, is the it uses that word mining as a metaphor. Okay. And it really helps understand if you think about um, how mining is done kind of traditionally, old school. It helps understand where they came up with this term. So, the practice of searching through large amounts of data to find useful patterns. So, you're not really asking specific questions, right? You're just letting the data speak for itself to see if there's anything worthwhile in there. And like I said in that first bullet, there are useful elements to the metaphor of why we're calling this mining. Okay, because back in the day, and we're talking traditional 18th 19th century, um, like the Klondike Gold Rush, the California Gold Rush. Um, People would prospectors, geologists, people that knew rocks and knew mining and knew how this stuff worked, would head out into the countryside and take a literally a pan with them, and they would pan for gold because that's the easiest way to see if you have what's called placer gold, which is just little tiny flakes and nuggets mixed in, ground down, and mixed in with the gravel in a riverbed. So they would go and they would prospect, but they didn't know if they were going to find gold or silver or maybe something else. While they're out looking around in undiscovered country, they might find copper. They might find coal, seams of coal. So anyway, yeah, it's just kind of like looking around for what might be useful, which is similar to what we do with data mining. Um, So you might have heard the term, maybe not. I hope that pans out, or well, that just didn't pan out. That's where the term comes from, is gold mining, and if you swirl some gravel around, in that pan with water, and you find some gold, then it panned out, and maybe you can start industrial scale mining. And these are on, these guys, these are all over TV, Gold Rush and all that, reality TV. So this is still going on today. So that's kind of the way to think of data mining. Is you're going out, you're not really sure what you might find, but hey, let's stick our pan in the creek and see what we find. So there are um, quite a few techniques. And again, I'm not a statistician or a data miner for that matter. But one big technique within the family of um, machine learning is clustering, where you pull in the data, but you don't really have a criteria for it like you would in supervised machine learning, like when you're doing a classifier. But you start to see types of things clustering, and that sort of um, technique is supports like shopping cart. People that bought this also bought that. If you do clustering analysis on shopping habits, you'll see um, that certain products were bought by certain people, and suggesting them to other people that are similar to that cluster, uh, often results in a sale. So using those sorts of things, but also looking for outliers, deviations from normal. That can be like an excellent performer that maybe you want to go dig into a little bit more. It might be a very poor performer and something that you want to avoid if the data point deviates. Again, classifiers are like fraud protection. But that's not really data mining. That's really applied machine learning classification. But doing something like, okay, so you've got a spreadsheet with 10 columns in it, and you don't really know what you're looking at. That's the whole point of data mining, is um, going from the unknown to the known. You can run a correlation matrix on those multiple columns, and the software, you can do this in Excel, you can do it in Python. Um, it'll look at each column in the spreadsheet against each other, so that you wind up, if you have 10 columns, you wind up with a 10 by 10 matrix that looks at how um, these variables correlate. Some of them will have no correlation with each other. Some of them will have very strong correlation, and that might give you some idea of, some insight, whether it's, linear regression or logistical regression, exponential correlation, whatever. Um, it'll give you some insight into the data. Okay, so that's data mining. You're not really asking a question because you don't really know what is in the data and how the data relates. That's kind of, to me, the bigger difference, as opposed to analytics. As we see in our uh, the article that I found that defined it, for continuous iterative exploration and investigation of past business performance. So this is taking historical data and doing like predictive analysis, so that you can see, okay, well, if we pump this much money into advertising, we can expect this much of a bump in sales. As we go through summer or winter, we can expect sales to drop by X%, so we can change production to a different product line or whatever, using um, structured, known historical data. This is just traditional analytics, like we're all really used to. Um, and it takes your data and it operationalizes it. It allows you to support decisions based on the data, that will impact, no kidding, impact operations, whether it's, more people, less people, more supplies, less supplies, changing what you're making, you name it. So, and of course, we have our data analytics lifecycle that we discussed before. So that's really the difference. Analytics is asking specific questions. Data mining is just looking at what you got out there. So hopefully this week we'll see some decent examples, and perhaps no one had any real experience with Python or R. So maybe some of you will have some experience with data mining, which, like I said, clustering, which I covered in that other lecture. Clustering with R is one good data technique, but there's others. There's Rapid Miner, there's R, there's Python. There's other tools out there. Hopefully, some of you have some experience with this stuff, and we'll share it, and we'll get some real discussion. So here's the the tech. I mean, it's two parts. What's the difference, and provide an example of how each is used. Um, Hopefully, you'll be able to share your your experience with how they're used, and we won't just get textbook answers and from journal articles. Although, please, support your assertions with journal articles. But it would be great if we could, if one of you or five of you had experience with this, and we could pick your brain. All right. As always, yeah, don't rely completely on that one article. Um, they are subsets of business intelligence. Make sure you watch that supplementary video. It's not on research methodologies, it's on R programming. Sorry about that. Okay. And as always, uh, questions and concerns, let me know.